Hello, maurieos 2019 Engineering Maths Weekly Quiz number 4 review. Hello, welcome. Well, we will go through the quiz this week. This is an opportunity to check out where you went wrong, perhaps to get a little bit of guidance as to how you could get a little bit better so that you can achieve maximum marks for your effort in exams and quizzes and what have you in the future. It's probably a good idea to watch the quiz and the review after you've done it, and maybe even have another go at it. So, in recognition of students who actually take the time to review and do things, I'm offering a small prize this week, and any student who can tell me where this photograph in the background has been taken will have their selection. They can select one item from one of the vending machines in the hub at Rotokari Hub. So one vending machine item. I'm expecting it to be in single digit terms, dollar wise. So please don't get your hopes up too far. It's just a little bit of a fun competition. Maybe a bar of chocolate or a drink or a bag of lollies or something like that to reward your endeavour in checking out the Engineering Maths review. So good luck with that, and if you can tell me where this photograph has been taken. So let's get over to the big screen now and get on with the show. So in this one here, we've got to make A the subject of the formula. So there's A there, and we want to get that on its own. But first of all, we want to deal with the pluses first. So what I would probably do here is that wasn't how that was expected to go. That was supposed to turn green. I've got to get back into things. So what I would do first up is I'm going to subtract u squared from both sides. Okay, so that then will give us, in red here, I've got to do it 2 taps. So that's going to give us v squared minus u squared, and that's going to equal 2as. So this is from both sides, remember, from both sides. I know that looks like bath sides, but from both sides. So we're taking, so there's the negative u squared off that side, and well, we can sort of take it off that side if you like. So there we go. Now we've got v squared minus u squared equals 2as. Now we want to get a on its own. So actually, I'll stay in green here. If we actually divided through by 2s, divided both sides by 2s, 2s, that'll give us a there, because that crosses out, the 2's cross out and the s's crosses out, and we end up with a on its own. And I like to have a on the left-hand side of the equation, so we can just come back here, and as you can see, we can have A equals V squared minus U squared over, I was just checking there, over 2S. And there you go. A equals V squared minus U squared over 2S. Well done. That's it. All over. Right, now for the next one, which is a simplification one. So we've got that one there done. Yep. Minus U squared from both sides. Yep. I don't think. Some questions are coming. You can write the answer in here or over there. Just be quite clear. So it might pay just to clearly indicate what your answer is. Put a line under it. Some people write answer, but yeah, no, that's all good like that. So, right. So now here's the next one. Simplify this. Right. Okay, so let's have a look at this exercise number 4.02. And what I'm going to do is leave the cube in place for now. And I'm just going to expand this out. So the x squared y to the power of 5 now the 8 here, the 8 is that is over, the 8 is 2 to the power of 3. So you've got to look at these numbers and sometimes recognize some of the powers. So 8 is 2 to the power of 3. Now the reason I say that is, of course, is if we take the cubed root of that, which is this is there, it's going to make it equal to 2. All right, now these are going to expand out, so we're going to go x squared there, x squared, and y squared, because we're just going to expand that out. And now we'll flip over to the green pen, and you can see then that x squared and that one there will cancel out. And this, we're going from the top. We've got 5y times y times y up there. So that can cancel out there, and we'll just go minus 2 over there, which 5 minus 2 is 3. So what we've got there now is just rearranging that. So we'll just put it equals. Oops, still not on the red. The equals there. And then we'll put an equals down here. I'll still leave the cube in place so that we can just see it more clearly. So we've got 5 to the power of 3. Oh, y to the power of 3, sorry, over 2 to the power of 3. Okay. Now, if we take the cubed root of that, okay, that's going to get rid of the third, and we just get y over 2. And just remember that that's equal to a third. So we could, I guess, go here times a third. To get rid of this here, and here times 1/3 as well. Okay, And that gives us y over 2. And there you go. It's all done. It's done, I say. It's done. Pretty easy, really. All right, now for this one, write as a single log. Okay, so we get down to this one here. All right. So we go. What do we do? Well, we get the red pen going first, so that's there. All right. So 5 log x is log, okay, x to the power of 5. Or, yeah, log of x to the power of 5. And plus 3 log y is log of y to the power of 3. Y to the power of 3. And then we've got minus log x squared y. Now remember, with logarithms it's plus if they're multiplied together. So log x to the power of 5 plus log y to the power of 3, that's equal to so that equals log x to the power of 5 y to the power of 3. Now minus is like divide, so we go over x squared y, which we could, so let's do this in green, we could say that's y to the power of 1 there, and then this here we can go 5, we can subtract 2 from there, that'll bring that one up to the top, and then we can y to the power of 1, we could subtract 1 from there. So what we get is our answer is equals log x to the 5 minus 2 is x cubed, or x to the power of 3, and 3 minus 1 is 2. So if we wrote that as 1 log, that's what it would be. Like that. That would be it as 1 log. Oh, I should have, just going up here, just should have underlined the answer there. Okay, equals, yep. So that's it all written as 1 log. Okay, log x to the power of 3. So 5 over 2 is 3, yeah, and y to the 3, yeah, there you go. That's all done. All right, so now we need to go to the second page. So to do that, we need to get layer 2, turn off layer 1, bring on layer 2, and let's go and have a look at that. And here it is. Okay, so this has got a bit of a... So the barometric formula for calculating air pressure P at height 8 meters above sea level can be expressed as P equals P0 minus E to the KH, negative KH, where P0 is the pressure at sea level and K is a constant. If the pressure is 101.3 kilopascals at sea level and 90.1 kilopascals at a height of 1 kilometre, find the value of K. Right, so let's fill in what we've got. If the pressure is 101 at sea level, okay, the pressure P at height h meters above sea level, so let's just putting that down here, let's just say it's going to be okay, so we're just having a little bit of technical problems there, so let's just make sure we've got this all right here, and there's our, oh, we can get rid of our layers, we don't just get that there. Oh, current layer is invisible. That's what the problem is. There we go. Okay, Control Z. Okay, I'll just check on layer. Oh no, I can do that. Okay, so here we go. Now, so we're on, should be on layer 2 now. So P, which is P 1000 P 1000 equals, which is, that's at the height, equals P0. So P 1000 equals 90.1. P0, which is at sea level, is that there's equal to 101.3. And then we've got E, which we know, to the negative K H. Okay. All right. And H now let's see the barometric formula for calculating at height h meters above sea level, meters, can be expressed as P equals P0, where P0 is the pressure at sea level and K is a constant. If the pressure is 101.3 kilopascals at sea level and a height of 1 kilometre, find the value of K. So H here equals 1,000 meters. So let's just check the barometric formula. The H in meters above sea level can be expressed as P. P0 is the pressure at sea level, which we've got there. So that's there's P0. And 90.1 is that's P1000 there. Okay, so we can fill in the thing here. So we can say 90.1 equals 101.3 E to the negative K 1000, because h is 1000. And we want to find out what k is. All right. So we've got to maybe do a bit of sort of rearranging of this equation. So we're going to divide through both sides by 101.3 in the first instance. That's both sides. Okay, so we're going to get then 90.1 over 101.3, okay, equals e to the negative k 1000 . Now if we take the ln, if we take the log of e, that'll just make it, the log of e to the negative k 1000 is log to the base e of that is negative k 1000. So what we do is we, undo that. There we go. So what we're going to do now is take the ln, so that's the natural log, ln. So we're going to take that of both sides. Alright, so let's just move the thing down here a little bit. And so that's going to give us, okay, okay, so we need to get the red pen out. Yep, so now we're going to go ln (90.1) over 101.3 equals negative k 1000. Now what we want to do is we've got to now put the green, hang on, I just want to undo that little dot there, put the green here. So what we've got to do here is divide through by negative 1000, because that'll get k alone, okay? Negative 1000, dividing. Okay, so we've got to put that over here. So we get negative 1000, and we'll just bring it all together on the one side. So that's going to get k equals ln (90.1) over 101.3, just a little 0.3 all over negative 1000. Okay, so now that's we're going to do that on the calculator, and first I've got to find my calculator. Oops, I should have prepared for this earlier. So here it is here. I've got a calculator down there, and I've got, there's my calculator there. Okay. Right, and I want to run always on top. And my calculator, I'm going to bring that over from here, click on that window and run always on top. Okay, and my calculator's sort of disappeared there a bit. I'm going to right click there and zoom it up like that there. Alrighty, that should put that there. And then I'm going to bring my smooth draw back and my calculator back. And right, so let's get calculating on the calculator here. I need to get it back here a little bit. So let's see what we've got. So we're going to have L. Right, we're going to start with a fraction, which is that one there, and then we're going to start with a an ln. Okay, and then we're going to go with another fraction, which is going to be 90.1. And then we're going to drop that down to there, which is going to be 101.3. And then we'll go like that, and we'll close that bracket there and drop down to here, and we'll go negative 1000 equals. And what do we get? 1.17. Right. So we'll move this over to here. Put this here, and we get K equals, we seem to have lost our that puts it on top. K equals 1.1716. Oh, I should be doing that. I'm doing it with the mouse instead of my 166 times 10 to the negative 4. Oops, that didn't go so well. 10 to the negative 4. And that equals, oops, let's get into the red zone there, so we'll undo that. That's the red zone. Equals 0. I should use the pen now. here we go. And just fixing up the brush strokes there. You might notice a change of shape there, 0.01716, which you could show, if you wanted to round that, is 0.0000117, three significant figures. And that would be our answer. Okay, so we might want to check that, and so the way that we check it, or let's do a check in purple or magenta. So the way that we check that, I'll just turn on some lights here. You might notice that I've changed my attire, so this is recording the next day. Okay, so we can put that back into there. So we know that that is P is what we're going to find out, which should be 90.1 is equal to P0, which was 101.3 times E to the negative K 0.0000117 times, and H was 1,000, just height in meters. And we can do that on our calculator. Just move the calculator over here. Control spacebar should lock it in place. So now we can go 101.3 times E to the negative 0.0000117 times 1,000. Oops. 1,000 equals 90.1. Let's check that again. 90.1. And 2 ticks. So that's a good check there that we've got that right. Now the reason that I stopped in the middle of this one is that I actually made a little bit of an error initially, and when I came back I found that I couldn't get 90.1 as my answer. So it is a very good check, and what I found I had done was when I had rounded up this number here, I had put it as 0017 instead of 117, and I was using that and I couldn't get the correct answer. So that's that one done, and now let's move on to the next one. Okay, so let's have a look at question 5. So what we have here is essentially something, a parabola, and it's a negative parabola, so it's sort of looking something like that. And then we've got a straight line. And the two of these things here, they intersect at these 2 points, here and here. So there'll be 2 intersection points. So we need to be aware of that. So, just going back to red. Oh, we could do that and then just flip them. Okay, so what we've got here is, and so at these 2 points, each equation is true. So y equals negative 5x minus 3 and y equals negative 3x squared plus 2 at each of those points. So what we can do is say, well, if we go here, y equals negative 3x squared plus 2, but it also equals 0.5x minus 3. And if we wanted to get rid of that 0.5, no, we couldn't. Okay, I'm sketch that idea. I'm not going to do that. Okay, so that's what we've got there. So now we can join those together and we can say, well, negative 3x squared plus 2 minus 0.5x plus 3 equals 0, because the 2, and that actually eliminates the y. You could actually sort of suggest a substitution as well. You could find out what x is in terms of y, or y is in terms of x, and there. But that's going to work like that. So just collecting the terms together, we've got negative 3x squared minus 0.5x plus 5 equals 0. And personally, I don't like multiply. I don't like the negative, and I don't like the 0.5. So if I multiply by negative 2, I'm going to get 6x squared plus x minus 10 equals 0. So what I did there is I just multiplied by negative 2. Okay, so that made that front one there negative, that one positive, that one negative, and it doubled everything. 6, 1. All right, now I want to factorize that, but looking at that, I don't think I can factorize it with just factorize it by I. So I'm going to use the quadratic equation So this here is equal to A, and this 1 here is equal to B, and this negative 10 here equals C. In the equation, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's come right over here and see what that looks like. X equals negative b, so that's negative 1. All right, negative 1 plus or minus the square root of b squared, which is 1, minus 4 times 6 times negative 10, all under the square root, and then that's all over 2a, which is 12. So that equals, we'll just drop it down here a little bit more. Okay, so that equals negative 1 plus or minus the square root of 241. So that's 6 fours are 24 times 10 is 240, it's all 241 all over 12. And you can see that you'll get two solutions. One is the positive solution and one is the negative solution. So x equals, so let's come over here and over here, perhaps we could bring this over here a little bit. So we've got square root of 241, square root 241 equals 15.52. So that's negative 1 plus or minus 15.52 over 12, and that equals, so x equals negative 1, negative 1 minus answer equals, divide 12 equals negative 1.38. Or negative 1 negative 1 plus 15.52 equals divided by 12 equals 1.21. Now we can substitute back into this, both equations actually. So let's see, when x equals 1.38, y equals 1.38, all clear, 1.38 times 0.5 equals minus 3 equals negative 2.31. Okay, and when x equals, oh, that should be negative 1.38. So that should be negative 1.38. I'll better clear. I'll just undo this, I think. It should be negative 1.38. Yeah. So negative 1.38 times 0.5 equals minus 3 equals negative 3.6, negative 3.69, and when x equals 1.21, y equals 1.21 times 0.5 equals minus 3 equals negative 2.4. So let's just do a check on those. And we'll check them in the other equation. So when x equals negative 1.38, y equals, so let's go negative, clear, negative 1.38 x squared times negative 3 equals oops, that's not right. We need to put Need to put a bracket in here, I think. Negative 1.38 squared times 3 equals plus 2 equals 3.71. There. I think that's close enough. Rounding errors and stuff. And when x equals 1, I think that's close enough, possibly. Does seem a little bit further out. But, yeah, and see how the other one goes. When x equals 1.21, y equals, oh dear, lost my calculator again. It's coming. Here it comes. Put it over there. Okay. Oh. Okay. Yeah. And when x equals 1.21, y equals minus 3 bracket 1.21 bracket squared plus 2.39. Yeah, which is close. Negative 2.39. Just confirm that. Negative 2.39. That's correct. Near enough. There's a little bit of error there, but good. So, therefore, the answer is oops, red up here. Therefore, points of intersection are negative 1.38 comma negative 3.69 and (1.21) comma negative 2.40. Okay, so that concludes today's, the review of Quiz 4. It was a little bit of a journey, but as you can see, it's not all straightforward, so one has to be very careful and very precise into what you do. And don't forget, there's a free gift at the vending machine if you can tell me where this photograph is. All good. Cheers. See you. Smash that like button.